Welcome to Energy Talks, the podcast for energy nerds and inquisitive folks who enjoy interesting conversation. I'm journalist Markham Hislop. Today's guest is Oscar Azofeifa, the CEO of PowerBox Technology, which operates in Latin America. And this is going to be a very interesting conversation because we're going to be framing this around the modeling that OPEC does about oil demand and electrification. So welcome to the to Energy Talks, Oscar.
Hi, Markham. I'm very happy to be here. I'm very excited to talk about topics that I'm passionate about my company, but also about my background and my unique perspective coming from Latin America and also creating a startup in the US. So
Well,
very
yeah,
happy.
we're happy to have you here, and I'm we'll get into your background and the company and what you're doing in Latin America. 'Cause I'm quite interested in your business model as well as your technology.
Yeah.
Um, but let first of all, I want to start at the kind of the 35,000 foot level here. So let me frame the conversation. We do a lot of work on energy demand modeling, particularly around oil and gas, because Canada perceives itself, it has this idea that it wants to increase production and build new pipelines to export its primarily oil, but also gas in the form of LNG. So the question then becomes, is there a market for it? And this is an issue that's not addressed well enough in the Canadian conversation. But I've done a lot of work on, looking at the various modeling exercises like OPEC, ExxonMobil, that do look at between now and 2050, where is oil demand likely to go? So OPEC says very clearly its primary assumption is that over the next 25 years, that oil demand will decline in the global north. So we're talking North America, Europe, China, Australia, South Korea, Japan, and so on. But it'll decline because of electrification and climate policies. So they expect a decline, but that decline will be not only offset, but more than offset by growth in the global south. So we're talking primarily Latin America, Asia, and Africa. And so we're testing that argument by looking at some of what's going on in the global south. And is it electrifying or will it stick with and grow oil and gas consumption? So based on that, just general like 35,000 foot view, what's your take? Will Latin America electrify or will it stick with oil and gas?
Yeah, so I guess the best way to answer this question is using my own experiences visiting. I go to Costa Rica almost twice a year. I'm trying to go three times, four times a year. So I am very connected, not only visiting, but also my first projects that you probably know already. My first pilots and projects are in Costa Rica. So I'm very connected to the industry there, energy industry and electrical industry. And since I've been going in the last 2, 3 years, I've seen a lot of changes on the transportation sector, which was always the main, let's say, not so beautiful side of the picture for Costa Rica. Always being in the news that 98% of the electricity is renewable, mostly from hydro. But the bigger issue was on the transportation side. So going there for the last 2, 3 years have been a big increase in cars, electric vehicles, mostly from China, of course. Um, and just this last year, or last time I was there, somebody told me, gave me a number that almost half of all of all electric, sorry, of all vehicles being imported to the country last year were EVs. So we're already today seeing that shift, and it just goes down to the very basics, which is unit economics. Once the EVs are just more efficient, electricity is it's much cheaper in Costa Rica. Why? Because you said it, Canada produces, like the big countries produce it. We don't produce this energy. We import it, and we pay a lot of money for that. But it turns out we have a lot of resources. We have hydro, we have solar, we have a lot of cheap energy. So it just goes down to the economics. People are already seeing that it's much cheaper, first, to buy a Chinese car, and second, to maintain, to operate that Chinese car.
Yeah, that's a very interesting question because this is an issue that the oil and gas industry never addresses. It talks about, oh, well, Latin America or the global South has this aging grid, these aging grids. They don't have enough power generation. How are they ever going? But oil and gas infrastructure is also very expensive
Eso.
and not always well developed in some of the countries. And furthermore, there's the issue of energy security, how you define that has shifted. It used to be energy security was the ability to import enough oil and gas to meet a country's energy needs at a reasonable price. Now, the focus has shifted. How do we generate energy domestically so that we don't have to pay for constant imports all the time? So if I'm importing oil and gas, I've got to have it every day. I've got to have X amount of units of energy imported. If I buy a solar panel, I pay for it once and I can
Yeah.
generate electricity for 30 years. If I buy an electric vehicle, it's more efficient and I can probably drive that electric vehicle for longer at a lower cost per unit, less maintenance and so on than I would for an internal combustion engine car.
Yeah.
So if I understand you correctly, that your take on that would agree with the perception in Costa Rica at least that electricity is the lower cost, more reliable, better approach to transportation.
Yeah, and I mean the that argument in itself, it does, once you see it on the ground, it doesn't make sense, because the whole idea with these new technologies is that where you consume, you produce, which you don't have an oil rig in your house, right? So you don't produce the oil in your house and then right away create have energy from that and then use it, right? And this is the beauty of these modern new technologies, that first, they are so cheap now, you can install it we have regular people, regular folks in Costa Rica just installing solar panels, day-to-day people just installing solar panels, directly tying them to their ACs or directly tying them to their cheap EVs. And it just makes a lot of sense. It just makes a lot of sense economically. And we're getting to a point where it's getting to a more of a mass adoption where, it's a breaking point, that's where things get even more interesting. Um,
Yeah, this is a point because you're working in your power systems engineer,
Pardon.
so you understand this stuff from a technical point of view.
Yeah.
And one of the what I'm seeing that I have to admit this is something I was not familiar with, but I think it's been around for a while now, and that is what they're calling balcony solar panels. So you
Yeah.
get maybe like 1,000 watt hour or 1,200 watt hour, and it's maybe 5 feet by 3 feet or whatever it is, and you just plug it you hang it on your balcony, you put it on your roof, you put it in your backyard wherever you've got sun, and boom, you plug it into your 120-volt plug-in in your house, and away it goes. You've
Yeah.
got power, and you can put any number of these things depending on how much room you got in your balcony or in your backyard, and at a very reasonable price, you've got
Yeah.
electricity. You
Yeah.
don't have to worry about whether the grid is able to supply you or not. Is that model catching on in Costa Rica and Latin America?
I gotta say, from my own experiences in Costa Rica going recently, I haven't seen as much of that, but I will definitely, definitely start seeing it. There is no barriers for entry for that. Um, I mean, I would say we're still behind with the net metering and the electrical infrastructures for distributed generation, but this is just completely behind behind them, not even behind a meter. It's just literally it's your own energy, and you're just using it right away, right? There's no legal framework for that. So uh, I think I'm gonna see an uptick on that, but going to what I'm doing with PowerBox, it doesn't even mean that all of your that's that's the only strategy, right? You can have a strategy where you are tied to the grid, but you're like making sure that electricity is consumed locally, which is what we are achieving with our technology. And that's with today, right now, technologies that make a lot of sense economically.
Let's talk about that. Give us a brief overview of your company and its technology and what it does, please.
Yes. So again, I'm gonna try to go back to my background and where this all started because I think it's a very important context. Um, you did mention that the electrical infrastructures all over the world, right? They're aging, but in Latin America in particular, they're really behind. They're really, really behind. Um, so this poses a challenge, right? So industrial manufacturing, it's much more expensive, the electricity or the operations of it in Latin America because reliability is much different, right? So I have numbers from the World Bank that show that businesses can lose from 0.5 to 5% of their sales annually. That's that's a lot, just because they don't have a stable electrical supply. And we're not talking about blackouts. We're talking about continuous brownouts or deviations from optimal conditions that happen every day. So in that context, like I always saw that working in Costa Rica as a junior engineer. And I back then, this was 10 years ago when I started seeing this, it was like, okay, we need to do something about this. Um, I see the Tesla battery being coming online, but it's way too expensive, and I don't think we're there yet to have a complete solution to solve this at a local level. But as the year passed, this just got cheaper and cheaper. And eventually I realized, hey, I think this is the right moment to start my own company and try to bring that technology that I'm implementing at the grid scale in developed economies. For context as well, I used to work for Varsila Energy Storage, big Finnish company, one of the biggest energy storage companies in the world. I realized, okay, this doesn't work in Latin America. You cannot sell bulk power. You don't have the infrastructure for that. So let's do some system that is designed to be 100% behind the meter for local optimization, and particularly focusing on industrial manufacturing because they lose just too much of their productivity because of reliability. So basically, what we're doing with our technology is we're enabling the 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 introduction of renewables uh, and localized sources of energy to be consumed 100% on site. But then at the same time, with our technology, we enable 100% electrical uptime. So what I mean by that is not even the smallest deviation on the grid, not even the smallest glitch will affect operations. And that has a big economic impact on those operations.
Okay, so I'm a factory in Costa Rica, and I'm losing 5% of my production a year, my sales, because of the problems with the electrical grid.
Yeah.
So you come in and you say, you can stay connected to the grid, Markham. Your factory should stay connected to the grid, but I'm going to bring some solar power generation. I'm going to bring some battery storage. I'm going to bring some monitoring software. And I will make sure that you have 100% of what you need at a reasonable price. And I'll actually take my profit from your savings.
Yes, correct. Yes. So we have initial, so we haven't executed this pilot, so this is not running live, but we have initial data because we have been getting a lot of data, running it through models. With the electrical rates or the electricity markets in Costa Rica, industrial rates, we're seeing savings of 50% from 45% all the way to 55% by adding enough solar and some energy storage. So that in itself, you will be saving half every year on electricity, and then using the numbers that you gave, like that 5% of losses in reliability, that means that they're saving. Let's use this example on a $20 million operation, they will be saving around $200,000 a year because of this, just because we eliminated this issue of reliability. So altogether, we will be talking about like a 2-year payback, which is just a no-brainer at that point. 2-year payback. They usually come and say we don't make investments for less than 3 years, right? In these industrial settings. No, no, no. You're solving that issue. You're not getting any headaches, and you're making your process more efficient, and you're saving all of this money. It's a no-brainer. So that's pretty much, these initial numbers we're getting, and I think once we have a very mature technology, it's going to be very easy to gain adoption in the region.
So if I understand your model correctly, Oscar, it's not like you've developed a whole lot of proprietary technology. You're taking a lot of technology off the shelf, which would be produced in China, I'm assuming. And I'm talking about solar panels and microgrids and inverters and all the other,
Yeah,
equipment that's required. You put it all together in a package. You have some monitoring software. That probably is your innovation that you bring to the table. And then you offer it as an energy as a service agreement, which is not
yeah,
my factory wouldn't buy it. My factory would enter into the agreement, and then we would pay you out of our savings. So I win, you win, everybody works. And this is a model we're seeing more and more in North America,
yeah.
is why I recognize it.
So
So
just
okay, so I've got this correct, right?
Yeah, so there is just one small detail. So we do develop some of the hardware, which is the power conversion, which I call the heart of the microgrids. The heart because it's what decide where energy is pumped from one place or controls the flow. So we do develop those systems in-house.
Oh, okay.
Here in the US, that's where we're doing the R&D because it's like a very important piece that needs to be very reliable, and also we are doing a proprietary design for that. And then the software, yes, the software is crucial to all of this. And then we work with the companies that will implement that model that you're talking about, that they buy our technology, and with our technology, we help it integrate the batteries, integrate the solar, integrate whatever, wind, uh, alternative fuels. We just have a modular system that makes that integration very easy. And then those companies, those ESCOs or service companies, right? They will install the complete projects and come, get to an agreement like that where they install and they run the operations, and then I don't know, they might lease or they might just, charge a fee, kind of that energy as a service type of agreement. So with our technology, we're enabling, let's say, that business model.
Are you providing a package that another company in the country, like in Costa Rica, actually does the work on the ground?
Yes, correct. So yeah, our customers, it's actually EPCs, service companies, engineering firms, companies that develop the projects, because these projects are, it's not only the power conversion systems that we design and the software, it's also the groundwork, installing the interconnection requirements, electrical equipment, et cetera, et cetera. So we are just kind of that missing piece that helps that integration, facilitates that integration, so they don't have to go and look for the different inverter providers and the different standards, and also the software provider ends up being very complicated and expensive.
I understand in Canada, where like in Alberta, what I'm most familiar with, the oil sands is a major industrial project, and so in Alberta, they've grown up this very large engineering sector, which has when you say EPCs, you're talking about engineering, procurement, and construction companies, as well as engineering firms. And so, if you were talking about bringing this model to Alberta, I could say, oh, I understand who excuse me, I understand who the industrial customers are. I understand the middleman, which is the EPC or the engineering firm, because there's lots of those around. They bring expertise and experience and so on. And then I understand your role, your company's role is to bring all of the hardware and the software and everything that the EPC would source and then install for its client. So I think I
Yeah.
understand the model. Where in like in Costa Rica, are all the pieces of the puzzle there? have you got lots of industry that you can that would be the end customer? Do you have enough EPCs and engineering firms to service those customers?
Yeah. There is a lot of well, we're working with a couple of companies, and also Costa Rica is very small, so just one engineering firm covers 30% of the market. So uh, we are already working with those companies. They since these are big projects and they require big capital investment, we're starting with a more, let's say, kind of a story to tell, like you have a live site that runs and it's very visible for people to understand the economics, and then we're gonna start scaling from there. But then in terms of finding all of the other technologies and the integration, all that, there is enough uh, on the ground to do it. There isn't enough capacity to do it. I mean, the technologies are just there. I guess that's the one thing I try to reinforce is the reason why this wasn't happening before. It was just because of the cost, right? The variable cost or the unit economics of these other pieces that are more expensive, right? The energy storage, the solar, the electronics, right?
This is a really important point, and it's part of our model, Oscar. We haven't talked about this yet, but Energy Media has an energy transition theory of change, and I'll very quickly describe it to you. What we do, it has two parts to it. The first one is clean energy technologies like solar, batteries, EVs, wind, heat pumps, whatever, are on the adoption S curve. And so many of our most of our audience will understand because we talk about this all the time. You know what an S curve is.
Yeah,
And they're at the bottom, they're moving to the right at the bottom of the S curve. They hit the inflection point at that curve where they then get on the hockey stick part of the S curve. And what we do is we track those, and we've seen all of the technologies I mentioned essentially hit their inflection point where they become competitive with the existing fossil, hydrocarbon based or fossil fuel based technology. They hit their inflection point in around 2020. So it's only in the last few years that we've seen these technologies actually make base, as you say, competitive on an economic unit basis.
yeah,
And and so now we're seeing China has the far and away almost a monopoly, not quite, but you know what I'm saying, on manufacturing these technologies. They're scaling up, they're driving costs down tremendously. And now countries like Costa Rica look at that and go, aha, 2, 3 years ago, this was not economic. Now it is economic. And not only that, we know that because China is driving these costs down, that it will continue to be cheaper and cheaper and cheaper per unit of production.
yeah.
And is that kind of how you're looking at it and how the customers and the countries are looking at it? Is this is a the business model has changed. It now favors electrification as
Yeah.
opposed to what we used to do before.
Yes, and I will add some other point on that, which I think it's great. It's beautiful that it's happening. These technologies are not only being you say like most of it is coming from China, but the knowledge is actually widely available. Like the knowledge of how to make a battery. Not only you don't only need lithium for batteries. In fact, a lot of the big CATL and BYD now are going into sodium batteries, right? Sodium is much more available. So I'm predicting you're gonna see a lot of much more production locally, right? Locally. So it becomes more of a day-to-day thing to have a battery. Where you use it, you produce it. Where the country is located with its own resources, it's gonna find what's the cheapest type of energy storage technology um, to implement there, right? Or in the region. And that's kind of using that vision. That's how I decided that also I didn't want to get into the energy storage business because it seemed like some things change every year. There's a new technology, it's getting cheaper. So I'm designing the system that sits in between, that is like communicating all of this. And we're trying to make a technology that is agnostic to this energy storage because I don't think we have even seen 20% or 10% of what this is gonna be end up being. Like the amount of different storage technologies, flow batteries now are getting popular. We have green hydrogen, we have alternative fuels. There's so much going on. So what we're thinking about is just, okay, let's just have a technology that is modular and flexible to be able to integrate all of these technologies that will come out. And I think countries, and particularly Latin America or the global South, is gonna start having more in-house development that are gonna drive the economics even further.
Yeah, there's a couple of wrinkles on this. One of them is that China is clearly positioning itself as and has for a long time, but in these advanced technologies, the factory to the world. I mean,
Yeah,
it will produce some of this stuff cheaper. They have supply chains, they have expertise, they have R&D. Why would you build a battery Sorry, why would you develop your own battery locally when CATL and BYD can produce lithium iron phosphate batteries or sodium ion batteries or flow batteries so cheap.
yeah,
But the key part here, it seems to me, is not the manufacturing of the technology anymore. That's almost like a solved problem. The issue now becomes the expertise that you're providing, which is to integrate those technologies into local economies, into local grids or national grids that are aging, and those present all sorts of they require local expertise and experience and knowledge, and that's the challenge. And it sounds like from what you're describing that in fact, the Latin America is beginning to grapple with that. It's beginning to say,
yes.
people like you are coming in and saying, hey, we do have the expertise, we can bring this technology, and it saves you money. It's economic for you.
Yeah. Yeah, yeah, you're totally correct. The challenge is not necessarily that on the economics, and we're seeing that even here in the U.S., right, where there is a lot of people wanting solar, or I don't know Canada as well, but at least here regionally, I know there is a lot of people wanting solar, commercial solar, and the pipeline for interconnection is crazy. They just don't get the permits quickly, and they have to wait a lot. Same with data centers. They really want to add a lot of renewable-based sources for data centers, and there is a huge pipeline for including those loads. So I think most of the challenges right now it's on the legal side, but I think people often confuse the legal side as just legal. I work on utility side of things as well, and I think I have a very good understanding of how the grid works. And there is actual technical reasons why it is complicated to integrate so much of the variable sources back into the grid. So that with that in mind, I also um, design the technology to make sure that interconnection is very simple, and it also doesn't require all of these different standards for distributed generation and selling that electricity back into the grid.
Yeah, the blackout that Spain had, the Iberia Peninsula had here not just a week or two ago, is really a
Good
lesson
example.
for all of us. And the lesson is not that intermittent resources, intermittent generation like wind and solar are the problem. The problem is wind and solar have become so cheap that they're now the generation source for utilities, but you can't run intermittent generation on a grid designed for thermal generation or nuclear generation or hydro generation. You have to have a different grid. You have to have grid forming inverters and
Yeah,
digitalization and all sorts of other things.
yes,
And it's funny how grid managers, grid system operators they've known this, but like in Spain, they didn't have enough storage. They didn't have
yeah,
enough of some of this other technology integrated yet they were adding like huge amounts of wind and
yeah,
solar, like
yeah,
70%, 80%. It was crazy.
yeah, yeah,
And
yeah,
but they didn't do the hard work on the other side, on the grid, and so it came back and bit them.
yeah,
And that's a huge lesson. And so the question here is, can Latin American grid operators and utilities can they make that shift to revitalizing and modernizing their grids while at the same time the distributed energy resources that you're talking about, the behind the meter stuff, also is integrated? I mean, this is complex, right?
yeah, yeah,
This is not a simple thing,
yeah,
what we're talking about. And I see it unfolding in the US, as you mentioned. I see it beginning to unfold in Canada. We see it unfolding in Europe at a pretty rapid pace. And can Latin America make the leap so that it modernizes in a reasonable, at a reasonable pace?
Yeah, and I think the the opportunity is in that many of these grids just the investment hasn't been made yet. So that actually ends up being an opportunity because now you can design those new investments and those new changes in the infrastructure around renewables more than, just having a big infrastructure already developed that we're paying for, that then, you want to add more of these and then it's, economically not as feasible, right? So I think it's actually a big opportunity for the Latin American governments to kind of make sure that the rulings and the standards and whatever is established for the grid operators uh, resolves around how to how to operate and how to manage these new type of energy systems and grids. And I'm pretty sure, I'm very confident we will see a lot of technologies like ours being part of the equation, because we're coming in a moment where just economically makes sense, and the technology is just there. It's just about implementation at this point, execution.
Well, let's talk about that. There's a lot of discussion around the availability of capital to finance these kinds of investments. And
Yeah,
so, on the one hand, we have the International Monetary Fund, the World Bank, and all sorts of green funds. I mean, our new Prime Minister, Mark Carney, used to be one of the leaders at the global level and on
yeah,
this particular issue. So we've got a bit of an insight into it from his experience. Um, but also, what we're seeing in Latin America in particular is China moving in a big way. I mean, we're
yeah.
seeing, President Lulu in
Mm,
Brazil just did a big deal with China and
yeah.
President Xi Jinping. They made the announcement, and so my perception of this is that China is coming in and saying, "Look, we want to sell you all this stuff." But you need infrastructure for us in order to do that. You need ports, you need grid upgrades, you need all kinds of stuff. We'll we'll help fund that through our Belt and Road Initiative, and you can pay us back over time. And so the some of the stuff, I mean, in the past it would have fallen on the Latin American governments, but now doesn't have to as much
Mm,
because the economics are so good that other private sector or other governments like China's are coming in and funding this. And it seems to me that Latin America is ready for an explosion of this electric technology in a way that it wouldn't have in the past with fossil fuel-based technology. I,
yeah.
I don't know. That's my take.
Correct.
What do you think?
No, no, you're totally correct. And I think um, in many countries, let's say in South America, maybe, they had some local production of oil, and it made sense, right, to bring these infrastructures. But there is many others that just for many, many years, just like Costa Rica and island nations, just couldn't have the cheap electricity because they were at the expense of importing. But now it is an opportunity, right? Now it is opportunity even for manufacturing to move into these areas. Why? Because it's new, because it's fresh, because you can start, it's a blank slate, right? You can start from scratch and have very cheap, reliable electricity. It's actually an opportunity. So I think I will see a lot of, I mean, China in the equation. I think it's yeah, it's important for the production of the raw material and the components and whatever it's necessary. But then let's say on the regulation side, on the infrastructure, I think we're gonna see more firms from potentially here in the US or bigger firms in Latin America acting. And yeah, it's gonna be interesting because it's just gonna be this connection of different entities trying to compete and trying to capture the market. I would say for the service operators of North America, look into Latin America because that's where the next iteration will be. I think this far it has been a lot of grid scale building in developed economies. I think the next iteration is going to be more behind the meter, distributed generation, and helping this to build these new grid infrastructures in Latin America or the global south. Yeah.
Yeah, there seems to be a model here where the grid gets upgraded, whether it's the American grid, which is actually kind of old and creaky on its own, right? I mean,
Yeah.
it has been underinvested in the American power grid for decades,
Yeah.
which is a real problem now that they've got 4 or 5% demand growth a year.
Yeah.
So there's on the one hand, there's investment into the grid to make it more efficient. You're bringing in carbon fiber transmission lines with capacity of 2 to 3 times what you could carry before, and you're bringing in grid technologies that allow you to be, so that the system can carry 25, 30, 40% more electricity than it could because it's more efficient now. Yada yada yada.
Yeah.
All of this kind of stuff is happening. At the same time, the grid investment is pretty expensive. And
Yeah.
so people are saying, well, you know what? What if we have, as a factory, we invest in a system like yours where we've got solar, we've got storage, we've got software, we've got all of the hardware to make this happen. So now we're both more resilient
Yep.
as demand grows and demand challenges arise on the grid. We're more resilient. We've lowered our cost, and we have control. And
Yeah.
businesses like that, right? They
Yeah.
they want to they love having control of their own destiny. So you've got this bottom-up distributed energy resource model emerging at the same time as you've got this top-down modernization of power grids, and the two seem to work together really well when I mean we're early days here yet, but
Yeah.
that seems to be the direction that I'm seeing.
Yeah. Yeah. And I think there was always this. I remember when 2016, 2017, when I was doing my master's here at the University of Illinois, there was this whole this all of these papers about the the infinite or like the loop that makes the electrical infrastructure or the business of utilities go down because people integrate more solar and start disconnecting from the grid. I don't think that happens. Why? Because we still need this, we still need transmission, especially in this country. The transmission and having such a vast infrastructure with so many regions that trade power in real time every day, it's what makes it reliable and also cost effective, right? I think we're just going to a model where we just have all, of course, we need the highways, we need the huge highways, which is transmission, but now we have a more also local and modern distributions level, more distributed even, that just will interact with that, right? It's not one or the other. I think it's going to be a very interesting mix, and I think utilities will have to evolve or are already trying to evolve in that direction. They know this is happening.
Well, let's talk a little bit about how your company got started because you're, of course, in Chicago. You're at the
Yeah.
University of Illinois. You work in a research park, University of Illinois Research Park, which seems kind of fascinating that you're from Costa Rica, come to the United States, get educated, and have worked in, of course, in Latin America. But you've chosen Illinois as your home base to develop this
Yeah.
technology. Tell us about that and why you did that.
Yeah, that's very uh very important to mention. So I before starting my own company, I did work for a startup. I had got some experience on the microgrid control space. This was back in Boston. Also worked for a recently acquired startup for around 3 years, 4 years. It used to be called Greensmith. It was acquired by Varsila. So I got that very first, fresh perspective of first how the industry was developing, but also how entrepreneurship works here in the US at least. And it just gave me this notion that I could do both. I could develop the technology from here because it's such a developed environment for business and entrepreneurship. And the universities are a great resource for that. but then with a global vision, right? I'm starting with Latin America, but it's a global vision. So in that, thinking, I decided, let's go back to Illinois. I studied there. I have great connections at the University of Illinois. And Illinois also has a lot of incentives right now. It's trying to grow a lot of the manufacturing sector and bring a lot of innovation. Just to give you an example, there is a Canadian EV company that does this kind of small buses for like like a more last mile type of transportation. And they're coming there as of last week. They signed an agreement to come and build here in Illinois, in Peoria, which is an hour and a half from here. So there is a lot of innovation happening. The government here is very progressive on policies to bring innovation and invest in clean technology. So it just makes a lot of sense. I'm benefiting from those investments. The University of Illinois produces so much of the talent here in the U.S. I think it's like 5,000 engineers every year or something. It graduates. It's crazy. So I have this fresh intake of talent. And then we have a global perspective because we're trying to, from here, have the home base for the technology and grow from here to the world, essentially. So that's how it all came together, essentially, um, for me.
Well, this is fascinating, Oscar, and I really enjoyed our conversation about what's going on and about the technology, and it's very interesting to see how you developed your business model. And so, good luck in the future. I think this is, the work that you're doing is consistent with the work that I'm seeing in other countries, like like in Asia. We're seeing it in India. We're seeing, where people are companies and entrepreneurs and engineers are looking at this and saying, "Hey, this is the future. It's now lower cost. It's now more efficient and effective, and it can be distributed in a way that the fossil fuel-based technologies couldn't." And when we talk, when we look at it, the International Energy Agency or other companies, firms that are doing energy demand modeling. It's this kind of innovation that you're doing down on the ground, multiplied many times, that is going to enable and why I'm fairly, well, not confident is not the right word, but I can. The trend is to do what you're doing, scale it up, lots of people like you, and that then leads to electrification of economies. And that is the trend, and I'm fascinated to see an example of this. So thank you very much for coming on the show.
Yeah. Thank you so much. Just wanted to add one last thing. If you share our website, people can see what we're doing, and we also open up the opportunity for people to be part of the journey through investment. We're doing this thing called equity crowdfunding. So if anyone that watches this show wants to be part of this mission that we're on, they can contribute. We have it open all there, so anyone can be an investor. But just in general, very happy to connect with anyone. Any interaction is super important, makes us learn, and makes us distribute our vision. And I thank you for giving us this opportunity, and I hope we stay in touch for future conversations as well.
Well, we certainly will. We'll look forward to hearing about the progress in your company. So thank you very much.
Thank you, Marham.